Morning, Algebra 1. Today we are talking about method 2 for solving systems of equations. So this method is really good if at least one of your equations has a y equals or an x equals. It doesn't have to. If it doesn't have one, then you can just solve one of your equations for either y or x. But there's another method we can use that we'll learn a little bit later that might usually works a little bit better than having to solve. So if we have at least one equation where it's a y equals or an x equals, we're going to use what's called substitution. The reason we can't always graph is because if we get fractions or decimals, our graph will not give us an exact answer. And in math, we really want an exact answer. If we're launching a rocket into space and we're a little bit off, that's going to cause our rocket to explode, right? So in math, it's really important that we make sure everything is completely accurate. So what we do is we're going to replace one variable into the other equation, and then we're going to solve that equation for the remaining variable. Okay? So it's called substitution. So the very first step is always to find your equation that has either an x equals or a y equals. So in this one, it's the second one. So x equals y plus 4. Okay. So if I gave you the equation 2x plus y equals 5, and then I said x equals 7, what would you do everywhere you saw an x in this top equation? Well, you would change that x right there to a 7. And then you could solve. We're doing the exact same thing here. Y plus 4 is just a number. So we're taking that number, and anywhere we see an x in the other equation, because it's an x equals, we're plugging it in. So now I have 2 instead of x. I'm putting y plus 4, and then I'm finishing my equation. So just like I did here, I had 2. Instead of x, I put what x equals, and then I finished writing out my equation. Now I can solve. So now I'm going to take this 2 and I'm going to multiply it. I'm going to distribute. So 2 times y is 2y, and 2 times 4 is 8. And then we still have our plus y equals 5. Now I need to combine my like terms. So 2y's plus 1y is 3y. Remember, I only change signs when I'm going across the equal sign. I'm not going across the equal sign right now, so I'm not changing signs. I'm just combining like terms. Okay, and then I still have my plus 8 equals 5. Now I need to start solving for y, so I'm going to subtract 8 from both sides, and I get 3y equals negative 3. And I'm going to divide both sides by 3 to get y equals negative 1. But I'm not done yet. Remember that my solution is an ordered pair. So it has to have an x component and a y component, because we're looking for a spot on a graph. And a spot on a graph has to have an x and a y. So now that I know my y value, I can choose either one of these, and I can plug y into it. It's almost always easier to choose the one that is already solved for either x or y. So I'm going to take x equals y plus 4, and I know that y equals negative 1. So anywhere I see a y, I'm going to put negative 1 in, and I'm going to solve that, and I get the answer x equals 3. If you leave your answer like this, it is not correct. You have to write your answer as an ordered pair. So as a point on a graph, because that is what it is. It's a point on a graph. So my final answer would be 3, because my x always goes first, negative 1, because my y is always second. Let's go on ahead and look at our second example here. So our second example has y equals some stuff. Okay, so it has y equals negative x plus 3. So now in my other equation, anywhere I see a y, I'm going to plug negative x plus 3 in. So I'm just going to start by rewriting this equation. X plus 4 times y, but y I know is negative x plus 3. And then I have to finish out this equation. Now I can go on ahead and start distributing and solve. So I have 4 times negative x and 4 times 3. So x plus, what's 4 times negative x? Negative 4x, and 4 times 3 is 12 equals 6. So I have x minus 4x plus 12 equals 6. I need to combine my like terms. So I have 1x and I have minus 4x's. I'm not going across the equal sign, so I'm combining them as is. So 1 take away 4 is negative 3x's plus 12 equals 6. Now I need to subtract 12 from both sides, and I get negative 3x equals negative 6. Divide both sides by negative 3, and I get x equals 2. Okay, so now I know my x value. Now I have to find my y value. So to find my y value, I have to plug my x back in, and I'm almost always going to choose this equation right here. It doesn't matter which one, I just prefer that one. So it's going to be y equals negative x plus 3. So y equals negative, because that is not the x value, that's just a negative sign. My x is 2 plus 3. So y equals negative 2 plus 3, which means y equals 1. Okay. That is not my answer. I have to write my answer as a coordinate. My x goes first, my y is second. Go ahead and take a look at this next one. Okay, so I have y equals, and it's 2x plus 8. So anywhere I see a y in the other equation, I'm plugging 2x plus 8 in. So I have 3x plus 2 times y, but instead of y, it's 2x plus 8. And then I have to finish writing that equation. So now I'm going to distribute. So 3x plus 4x plus 16 equals 9. So 3x plus 4x, I need to combine my like terms. And I get 7x plus 16 equals 9. I'm going to subtract 16 from both sides. And I get 7x equals negative 7. Divide by 7 on both sides, and I get x equals negative 1. So I know my x value, but I still have to plug it back in and find y. So I'm going to write either one of my equations. I told you I almost always use this one. I'm just going to use this one this time. So 3x plus 2y equals 9. But instead of x, I know it's negative 1. So 3 times negative 1 plus 2y equals 9. So negative 3 plus 2y equals 9. Add 3 to both sides. And I get 2y equals 12. Divide both sides by 2. And I get y equals 6. So that's the reason I almost always plug it into the original one, because this one, 2 times negative 1 is negative 2, plus 8 is 6. It just usually is a whole lot quicker. Okay. But I'm not done yet. I have to write this as a coordinate where my x goes first and my y is second. Let's take a look at the next one. So I'm going to circle my value that's alone. It's an x. So now I know that x equals 4y plus 11. So anywhere I see a y in my other equation, I'm just going to put 4y plus 11. So I have 4 times 4y plus 11. Oh, I made a mistake there, didn't I? Anyone else catch that? That's my x value. So anywhere I see an x in my other equation, I'm going to put that value. Reason I knew I was wrong when I started writing it out is the whole reason I do this is so that I only have x's or y's in my equation. Okay, so that's going to be a 4y minus 5 times, now it's 4y plus 11, and then I need to finish writing out that equation. So I have 4y, I'm going to distribute, minus 20y minus 55 equals 9. I need to combine like terms, so 4y minus 20y is negative 16y minus 55 equals 9. Add 55 to both sides, and I get negative 16y equals 64. And now I need to divide both sides by 16, by negative 16. And I get y equals negative 4. Now I need to choose one of these to plug my y value back into. So x equals 4y plus 11. But I know what y is, so x equals 4 times negative 4 plus 11. And x equals negative 16 plus 11. So x equals negative 5. But I'm not done yet. I have to still write this in coordinate format. So my x goes first and my y is second. So let's go ahead and take a look at this next one. So this next one, both of these are y equals. So it doesn't matter which one we choose. I'm just going to choose the top one because I don't know, I just am. So I know y equals 2x. So in my other equation, anywhere I see a y value or a y, I'm going to put 2x in. So instead of y here, I'm going to put 2x, and then I just have to finish out that equation. I need to solve for x. So remember that anytime I'm solving for x, I need to get my x or y. I need to get my variables on one side, so my x or y on one side, and my numbers on the other. So I'm going to go ahead and subtract x from both sides, and I get x equals 5. Okay, so now I know x equals 5. So now I can choose either one of these, and I can plug 5 in where I see x. So that's going to be y equals 10. So my answer then is 5, 10. So the cool thing is that you can check any one of these answers, including your graphing ones from the other day. How you do that is you just plug those x and y's back into both equations. So I'm just going to write my first equation, y equals 2x, and I'm going to write my second one, y equals x plus 5. Anywhere I see a y, I'm going to plug my y value of 10 in, and anywhere I see an x, I'm going to plug my x value of 5 in. So 10, I can't do anything with that. 2 times 5 is 10. That's checked. Okay. So I'm just plugging and making sure that it's a true statement. Okay, so this one right here, y is 10, x is 5. So now 5 plus 5 is 10. That's true. It checks. So I know that I'm good. Okay. I know 100% that this is the right answer. Let's go on ahead and do one more problem. Okay, so this one has a y equals x plus 3 and a y equals 2x plus 5. So I'm just plugging this one in. Anywhere I see a y in my other equation, I'm putting x plus 3 in. So now I'm going to have x plus 3, that's in for my y, equals 2x plus 5. I need to get my x's to one side and my constants to the other. So I'm going to subtract x from both sides first, and I wind up with 3 equals x plus 5. Now I'm going to subtract 5 from both sides, and I get negative 2 equals x. So that's my X value. Now I need to plug X back into either equation to solve for Y. And so Y equals, my X value is -2 plus 3. -2 plus 3 is 1. So my answer now, remember, has to be written as a coordinate. We're actually going to work a couple of word problems now. So let's read this first sentence. It says, Kim is 6 years older than 3 times the age of Dan. So in this problem, I'm going to use K's and D's instead of X's and Y's so that I remember who's Kim and who's Dan. We also need to remember that anytime we're doing a word problem, is equal to, equals, any of those terms, was stands for the equal sign. So we know that Kim then equals, and it says 6 years older. So that means I'm adding 6, and I'm adding 6 to 3 times the age of Dan. So 3 times Dan's age. So now let's go on ahead and do the second part of this problem. It's a system of equations, so we have 2 different equations at least. It says 8 years ago, Kim was, okay, so 8 years ago. So how am I going to write that Kim's age 8 years ago? Well, I'm going to write Kim because that's how old she is now, and I have to subtract 8 from it. Was is the equal sign, and then it says 2 years less than. So that means I'm subtracting 2, less than 9 times Dan's age. So 9 times Dan's age, oh, but Dan's age 8 years ago. So that's 9 times whatever Dan, however old Dan was 8 years ago. So now I need to find the ages of both Kim and Dan. So I know my K equals 3D plus 6. So anywhere I see a K in my other equation, I'm just plugging 3D plus 6 in. So that's going to give me 3D plus 6 equals, minus 8. See, I forgot that. Minus 8 there. Equals 9 times D minus 8 minus 2. Sorry about that. Let's continue. So now I'm just going to work to solve this thing by combining like terms, okay, and by distributing on the right here. Okay, so on the left, I can combine my 6 and -8, and I get -2. And on the right, I can multiply 9 times D and 9 times -8. Okay, so now I can continue. 3D minus 2 equals 9D, and -72 minus 2 is -74. And now I'm going to have to move my D's to one side and my numbers to the other, and it doesn't matter which side. I'm just going to subtract 3D from both sides. So I get -2 equals 6D minus 74. Then I'm going to add 74 to both sides. And I get 72 equals 6D. Divide both sides by 6. And 72 divided by 6 is 12. So that means that Dan is 12 years old. And yes, some of my students already said, why couldn't they just tell us the ages? Because we're making you practice word problems. So let's go on ahead and let's now find Kim's age. I know that Kim, her age is 3 times Dan's age plus 6. So Kim equals 3 times Dan's age, which is 12, plus 6. So Kim equals 36 plus 6. So Kim then is 42 years old. Now in these word problems, we're not going to write this one as an ordered pair, even though technically on a graph, it would be where they touch, okay? But we're talking about people's ages and it's a word problem. So we're just gonna say, hey, Dan is 12 and Kim is 42. The next one says the sum, what's a sum? That's addition of 3 times Mike's age and 2 times Jill's age, so we're adding those two things up, that's our equal sign, 54. We also know that Jill is 8 years less than, twice the age of Mike. So we know that Jill is, that's our equal sign, 8 years less than, so we got to subtract 8, twice the age of Mike. So now we have our J, so anywhere we see a J in the other equation, we're going to plug 2m minus 8 in. So that's going to be 3m plus 2 times 2m minus 8 equals 54. So now I'm going to go on ahead and distribute. So 2 times 2m is 4m, and 2 times negative 8 is negative 16. I can combine my like terms. 3m and 4m is 7m minus 16 equals 54. Add 16 to both sides, and I get 7m equals 70. So 7m equals 70, divide both sides by 7, and I get m equals 10. So Mike is 10 years old. So now I need to find Jill's age. So I know that Jill is 2 times Mike's age minus 8. So Jill is 20 minus 8. So Jill then is 12. So word problems, you guys have to start looking more and more at word problems because you're going to be working with them more and more. So the last thing we're going to do today is we're going to talk about inconsistent and consistent lines. So we talked about this when we dealt with our graphing, and it's going to be the exact same thing. Okay, so when two lines do not intersect, they are parallel. So this is called inconsistent, and our system is no solution. So what we will get here is we will get something at the end that looks like 3 equals 4, which can never, ever, ever happen. Or 2x equals 3x as long as x is not 0. Can never, ever, ever happen. So that's inconsistent or no solution. And remember, the symbol for no solution is that circle with a slash through it. When two lines do intersect, the system is called consistent. If they intersect at one point, then that system is independent, and the solution is the coordinates of the one point. So that's what we've been getting. Okay, x equals this, y equals that. But if the lines are the same line, then our solution is infinitely many solutions. So what it'll look like here when we solve is that we'll get something like 3 equals 3 or 2x equals 2x, which can always be true. Okay. So let's go on ahead and take a look at two systems here, two different systems, and solve them and then classify them. So the first thing, I have a y equals x minus 3. That means anywhere I see a y in the other equation, I'm going to plug x minus 3 in. So I have x minus, and then that's x minus 3. Notice I put that whole thing in parentheses because that minus sign is not part of my y. Equals 3. So now I need to distribute. So I get x minus x plus 3 equals 3. Now I'm going to combine like terms. X minus x is 0. So I'm left with 3 equals 3. So this one right here, our solution is infinitely many. Okay. 3 is always going to equal 3. And because it's infinitely many, that means that to classify it, it's consistent and dependent. Okay, it is the same exact line. Okay. So let's go on ahead and take a look at the next one. So it says y equals negative 2x plus 5. So anywhere I see a y in my other equation, I'm going to plug negative 2x plus 5 in. So I get negative 3x plus 3 times negative 2x plus 5. Now I need to finish writing this equation out, equals 6. So now I'm going to go on ahead and distribute. So I get negative 3x. 3 times negative 2x is negative 6x. And 3 times 5 is 15 equals 6. And going ahead and combine my like terms. So negative 3x and negative 6x is negative 9x plus 15 equals 6. Now I'm going to subtract 15 from both sides. And I get negative 9x equals negative 9. Divide both sides by negative 9, and I get x equals 1. Okay, so because I got x equals only one number, I know it's going to have one solution. So now I can plug this x back in to find out what my solution is. So y equals negative 2 times 1 is negative 2 plus 5. So y equals 3. So my solution is 1, 3. And since it had at least one solution, it's consistent. Because it did not have infinitely many, it's independent. We're going to continue seeing these consistent, inconsistent, dependent, and independent, okay, throughout the chapter. So make sure that you really understand that. So that is it for today. You guys have a great day.